Kia ora, and welcome to the December Jodcast from Space Place at Carter Observatory in Wellington, New Zealand. We're really noticing our days getting warmer now and our evenings getting brighter as we head towards the Southern Hemisphere summer solstice on the 22nd of December. The eastern evening sky is dominated by our summer constellations of Taurus and Orion with his two dogs Canis Major and Canis Minor. The summer Milky Way stretches through these constellations and along our southern horizon. Whilst not as bright as our winter Milky Way, we can still pick out the mottled glow of bright and dark regions when observed from a dark location. The bright regions are the combined light of the many distant stars that form our galaxy, whilst the dark patches are clouds of interstellar gas and dust that block the light from more distant stars. Throughout this region, there are many star clusters and nebulae that can be observed with binoculars and small telescopes, and some that can even be seen with the naked eye. We'll start our tour of the southern skies in Orion, sitting high in the east after dark, and easy to find by the three bright stars that form his belt. Here in Aotearoa we call these Tautoru, meaning line of three. As he lies along the celestial equator, Orion can be seen at least partially throughout the world. Above Orion's belt is a line of faint stars which form Orion's sword. But in New Zealand we see him upside down, so instead his belt and sword become a pot or saucepan. In Greek mythology, Orion is a hunter, and the arch-enemy of Scorpius, our winter constellation. The two continually chase each other around the sky. Just as one rises in the east, the other sets below the western horizon. At the top left of the constellation is the bright blue-white supergiant Rigel or Puanga. Whilst Rigel has been given the beta designation, it is in fact normally the brightest star in the constellation, and the seventh brightest in the night sky. Its colour tells us that it is extremely hot, with over twice the temperature and many tens of thousands of times the luminosity of the Sun. With an estimated age of just 8 million years, compared to 4.5 billion years for the Sun, Rigel is a young star, but has already used up all the hydrogen in its core and has swollen out to between 79 and 115 times the Sun's radius. Hot, massive blue stars like Rigel don't live very long. They live fast and die young, using their fuel quickly before meeting a violent death. Over the next few million years, Rigel will expand further and cool to become a red supergiant, before ending its life in a massive explosion called a supernova. At the bottom right of Orion is Betelgeuse, a star that has already reached the red supergiant phase, bloating out and cooling down to give it its wonderful red hue. Betelgeuse is designated Alpha Orionis, but is currently the second brightest star in the constellation. Estimates of its mass range from around 8 to 20 times that of the Sun, and if it were placed at the centre of the solar system, its surface would reach out almost as far as the orbit of Jupiter. One day, Betelgeuse is going to end its life in a supernova. Of course, soon to astronomers could be 1 million years, but if it does go bang within our lifetimes, it's sure to be a spectacular sight, perhaps becoming so bright you could see it in the daytime. At a distance of over 600 light-years, it is possible this explosion has already happened, and we're just waiting for the light to reach us. But, as well as stars at the end of their lives, Orion also contains stars whose lives are just beginning. If you look carefully, you may see the middle star of Orion's sword has a fuzzy appearance. This is the Great Nebula in Orion, or M42. The Orion Nebula is a stellar nursery, a huge cloud of gas and dust in which new stars are being born. At around 1,344 light-years away, M42 is the closest massive star formation region to the Earth, with around 700 stars in various stages of the star formation process. In the heart of the Orion Nebula is a small group of bright stars known as the Trapezium cluster. The ultraviolet radiation from these stars is lighting up the surrounding gas. Whilst easily spotted with the naked eye, through binoculars or a small telescope, the nebula is a wonderful sight. Take your time and you should be able to clearly see some of the nebulosity of M42 and the bright star cluster that lights it up. Another nebula in Orion that is well worth a look is the Reflection Nebula M78, easily found as a hazy patch in a small telescope. With a larger telescope, the famous Horsehead Nebula, silhouetted against the emission nebula IC434, is a lovely sight just to the south of the star Alnitak, the easternmost star in Orion's belt. Its proximity to bright Alnitak makes viewing the Horsehead Nebula more challenging, but long exposure photographs will reveal much more detail. Following Orion's belt to the left, we come to an upturned V shape of stars marking the head of Taurus, the bull. At the bottom of this V is the bright orange star Aldebaran at around 65 light-years away, representing the eye of the bull. The other stars in the V are part of the more distant Hyades cluster. At 153 light-years away, the Hyades is the closest and one of the best studied open clusters to Earth. It is estimated to be around 625 million years old. Over time, the cluster will continue to spread out and disperse into space, with some of the largest and brightest members already coming towards the ends of their lives. Near to the fainter of the two horns of Taurus and just about visible in binoculars under excellent conditions is the Crab Nebula. First discovered by English astronomer John Bevis in 1731, the Crab Nebula is a supernova remnant now believed to be associated with supernova SN 1054, observed and recorded by Chinese astronomers in 1054 AD. Continuing further around the sky, you come to another famous open cluster, the Pleiades, or M45, at a distance of 444 light-years away. This group of stars is even younger than the Hyades and is dominated by a number of hot, massive blue stars only around 100 million years old. The Pleiades has many different names in many different cultures, but here in New Zealand is known as Matariki, meaning little eyes or eyes of God. The rising of this group of stars for the first time before the sun around June each year marks the coming of the Maori New Year. Following Orion's belt to the right, you come to Sirius or Takarua, the brightest star in our nighttime sky, and in the constellation of Canis Major, Orion's large hunting dog. Canis Minor, the small dog, is a little below, close to the eastern horizon. It contains just two bright stars and looks like a single line when traced on the sky. Here at Space Place, we like to call it the hot dog constellation, as that's the only dog we know of with no head, no legs, and no tail. The brighter of the two stars, Procyon, is one of the Sun's nearest stellar neighbours at just 11.46 light-years away. Whilst it appears as a single star, the eighth brightest in the night sky, it's actually a binary star system, consisting of a white main sequence star and a faint white dwarf companion. From Orion and his hunting dogs, you can follow the band of the Milky Way around the sky, through the False and Diamond crosses to Crux, the Southern Cross, low in the south. Scanning a pair of binoculars along the Milky Way should pick out glowing gas clouds and numerous star clusters, whilst revealing much more detail than the eye can see. Both Mercury and Saturn quickly disappear from our dusk skies this month as they move closer to the Sun, leaving our evenings bereft of bright planets. Mars is the first to rise around 3:30 AM at the start of the month, with Jupiter joining it around 40 minutes later. By the end of December, Mercury will also reappear in the morning, rising rapidly up the dawn sky to sit just below Orange Antares. We also have a number of meteor showers happening this month. The Phoenicids reach their peak on 6th of December and are thought to be associated with the comet D1819 W1 Blancpain. With the radiant in the constellation of Phoenix not far from Achernar, this shower is well placed for Southern Hemisphere observers throughout the hours of darkness. The Phoenicids were first discovered during an outburst in 1956, where approximately 100 meteors an hour were seen from locations across the Southern Hemisphere. However, activity is very uncertain, and rates since have been much lower than this. The minor Papid-Velids meteor shower also reaches its peak at around the same time with a zenithal hourly rate of around 10. However, the radiant will only rise around 14 degrees above our horizon, so we may only get around 3 an hour. Just a few days later, peaking on the 15th of the month, are the Geminids. The Geminids are one of the best meteor showers of the year, but we're not well placed for viewing in New Zealand, with the radiant in the constellation of Gemini and well north of the equator. The constellation is at its highest around 3 AM, but still appears low in our northern sky. Due to this low height, we only see around half of the meteors visible to those in the northern hemisphere. Wishing you clear skies and a Merry Christmas from the team here at Space Place at Carter Observatory.